everyone. Today we will talk about the topic floating of ice on liquid water. Yeah, you can see here ice, right? So it floats on liquid water. So floating of ice on liquid water. Now water is one of the few substances that are less dense as a solid than as a liquid. If I say ice is solid, but it is less dense. Its density is lesser density as compared to the liquid water. So ice will float on liquid water. When other materials contract and become denser, they become denser when they solidify. But when water solidifies, when it freezes, it becomes less dense. Everything is because of the hydrogen bonding. At the temperature above 4 degrees Celsius, the water will behave like other liquids. That is, when it warms, it expands, and when it cools, it contracts. But all things above 4 degrees centigrade. So if I say at temperature above 4 degrees Celsius, what happens? All liquids, including water. What will happen? When the water will warm, it will expand, and when it will cool, it will contract. Clear? But when the temperature falls from 4 degrees to 0 degrees, then water begins to freeze, and because more and more of its molecules move slowly to break the hydrogen bonds. Clear? At 0 degrees, the molecules become locked into a crystalline lattice. Here you can see. So each water molecule is hydrogen bonded to 4 partners. If I say this water molecule, 1, 2, 3, and then backside it will be 4. It is 2D image, right? So in 3 dimensions, each water molecule will be bonded to 4 partners, and the hydrogen bonds will keep the molecules, see here, at an arm's length. So the ice becomes 10% less dense than liquid water at 4 degrees centigrade. If suppose this is the liquid water at 4 degrees Celsius, then the ice will be 10% less dense. Okay. Now if I say arm's length, it's simple, that is a stable distance. Clear? It is not the length of your arm. Simply at a stable distance, the molecules are from each other. Okay. So at 4 degrees centigrade, water is liquid, and at 0 degrees centigrade, it is solid. See, centigrade is old word term, and Celsius, I think it was given in 1948 or something to honor Sir Celsius. So both are same things. Okay. Anyways, ice is 10% less dense at 0 degrees centigrade. Okay. Now, when if I say how ice melts, simply it absorbs heat for its temperature to rise above 0 degrees Celsius, and then the hydrogen bonds will be disrupted. The crystal structure, this structure will collapse, and the ice will melt, and the molecules will have fewer hydrogen bonds, allowing them to slip close to each other. Water reaches its greatest density at 4 degrees centigrade. Okay, so water has greatest density at 4 degrees greater Celsius. Okay. Now, after that, it starts to expand when the molecules move faster. So, if I say when more temperature is there, the molecules will move faster, so the water will expand and density will decrease. So, the greatest density of water is at 4 degrees centigrade. Even in liquid water, many of the molecules are connected to each other by hydrogen bonds. You can see here. Clear? But transiently, the bonds continuously break and reform. So these are unstable hydrogen bonds, while in ice it is stable. Okay, so water molecules in liquid state are closely held by weak hydrogen bonds, while in solid the bonds become stable. Clear? And the molecules are at fixed distance from each other and ice is less dense. Okay, now this is a very important factor in making the life suitable. Clear? Suppose if ice sank, then all pond, lake, everything will freeze solid. And then life will be impossible on earth. See, when if I say there is ice on the water, in the ocean, suppose ice is there, so ice acts as insulator and below it water does not freeze, allowing life possible. In summer, only the upper few inches of ocean will be warm, but instead when a deep body of water will cool, the ice will float and life will be there below it. Because the water below is insulated and now does not freeze. Clear? Now, this ice also acts as a solid habitat for some animal. For example, polar bears, seals, they can come here. Clear? They hunt from here. Polar bears hunt from here, seals rest here, and then they enter water and they get their food from water. But polar bears, they have to take rest on this ice and then wait for seal or any organism to come out of water and then they will eat. Okay, now because of global warming, the ice is melting. Global warming is because of increase in greenhouse gases these days. The average temperature has risen in Arctic. If I say in Arctic, the temperature has risen by 2.2 degrees Celsius just since 1961. So this affects the seasonal balance between Arctic sea ice and liquid water. So the ice is forming much later in the year and it melts earlier and it covers a very small area, and the rate at which the glaciers and Arctic sea ice are disappearing will pose extreme challenge to animals that depend on ice for their survival. For example, see, polar bears. Now they have to swim long distances to get food, and young cubs cannot keep swimming for this much distance and many times they die. If ice is there, it's easy for them to wait on the ice, and if some animals come here, they eat. Ice acts as hunting ground for them. But now the ice is melting. These beautiful birds, these are black guillemots in Alaska. Actually, they have to fly from their nest. Their nest is on the land, and then they have to come down to the ice edges, you can see here on the edges of the ice they come and hunt for fish here. So for fishing they come here, clear? Now the ice is melting, so it's a very difficult for survival for these birds. Then you can see this beautiful black guillemots. Now if I say here, you can see stampede. Actually this is Pacific walrus. You can see the overcrowding and deadly stampede here on the land. Actually normally they will go on ice, clear, and then properly wait for their food, their breeding grounds and all. But now as the ice is melting, they have to go on land and it's overcrowded and many walruses die. Okay. Now as the temperature of the water increases, phytoplankton will increase. In fact, harmful algal bloom will be there. That is also a very dangerous thing. So phytoplanktons increase will be there, and zooplankton seed, phytoplankton, so they will also increase. Then algal bloom, that is also very harmful, that will be there. Now there are some organisms like bowhead whales and some fishes. Their temperature may increase because more food, plankton will be available for them to eat. Although the bowhead whales and all, because of fish, because of hunting, their population has decreased. But if we keep these things apart and say just planktons are increasing, then their number might increase. Their head is like a bow, so we say bowhead whales. Bowhead whales. And then this is a mammal, and then some fishes, their number also may increase. This is diagram only, this is real one. Okay, this much for today. Thank you.